Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our studies on laws of indices. Laws of indices. We have about 5-6 laws of indices. Before one can be able to understand and solve indices questions, one has to be able to understand these laws and then apply it in solving of what? Indices question. The first law that we have on our list is when the number is of the same base, we add the exponent. So all that we are trying to say is that when we have an indices notation that has its index and a base, and then these two bases or these two or more bases if these two or more bases are having the same base number, what we are just going to do is to just add what? The exponent. So for example, we are just saying that we have a raised to the power 4 multiplying a raised to the power 2. Since they are having the same base here and the base is what? A, what we are going to do is just to add the exponent. So here you just write 1a and then add the exponent. So here will be a raised to the power 4 plus 2. Since they have the same base, you are just going to add the exponent 4 and then 2. So 4 plus 2 is going to give us what? 6. So we are going to get our final answer to be a raised to the power 6. Right? So this is an example to the letters that you have seen here. So we are saying that 4 raised to the power 2 times 4 raised to the power 3. Here we are having the same base as what? 4 and 4. You are just going to pick one of the base and then just add the exponent. So you are going to have 4 raised to the power 2 plus 3. And 2 plus 3 is going to give us 5 as what? Our final answer. So you are going to have 4 raised to the power 5 as our final answer. And then the second example here is we have 5 raised to the power 8 times 5 raised to the power 6 times 5 raised to the power 7 times 2 raised to the power 2 times 3 raised to the power 4. We have this expression and we have been asked to solve them. Right? Since we are having two different bases, the law says that when the number is of the same base, we add the exponent. But you can see clearly here that not all the bases are equal. We have 5 as a base and then 2 as a base. And then the 5 as a base is repeating 3 times and then 2 as a base is repeating 2 times. So what we are going to do is just to group the bases with their like terms, right? So we are going to group the 5s, we are going to group the 2s and then just add the exponent. So here we are going to have 5 raised to the power 8 plus 6 plus 7 because we are having five base digits that are the same. So you are just going to add the exponent. So here you are going to have 5 raised to the power 8 plus 6 plus 7 times 2 raised to the power 2 plus 4. Since they are having the same base, you are just going to add the exponent. When you add everything, you are going to have 5 raised to the power 21 times 2 raised to the power 6. So this will be what? Our final answer. So the second law on my list is when number with the same base are divided, we subtract what? The indices or the exponents, right? So here if we have a raised to the power 4 dividing a raised to the power 2, all that you are going to, since they are having the same base, you are just going to subtract the exponent. So here will be equal to a raised to the power 4 minus 2, which will give us a raised to the power 2. Since you are subtracting 2 from 4, we are getting 2 here. And then this same expression can be written as a raised to the power 4 divided by a raised to the power 2, right? The division sign here is the same thing as what you have seen here. So either in the exams you see this or you see that. When you see either this or that, we are applying the same thing that we just learned. So for here, we are having our first example. We are having 4 raised to the power 3 divided by 4 raised to the power 2. Since they are having the same base and dividing, we are just going to subtract the exponent. So here we'll give us 4 raised to the power 3 minus 2, which is going to give us 4 raised to the power 1. And we know that 4 raised to the power 1 is also going to give us 4. So our final answer here is what? 4. Right? Our final answer here is what? 4. And then we are having another expression. 2 raised to the power 8 divided by 2 raised to the power 4 divided by 2 raised to the power 2 times 2 raised to the power 8. So all that we are going to do is that, you see, we are having division and then we are having multiplication. And the multiplication, we learnt it at the top there, right? We learnt it here that if the base are of the same, we add the exponent. But here we are having base that are multiplying each other, and then we're having base that are dividing some part of what the expression. So what we are going to do is just to focus on the division one. Once we are done with the division one, we go to what the multiplication ones, right? So here we are having 2 raised to the power 8 divided by 2 raised to the power 4 divided by 2 raised to the power 2 times 2 raised to the power 8. So we are just going to focus on the division ones. So here we are going to have 2 raised to the power 8 minus 4 minus 2. This is going to give us 2 raised to the power 2, because 8 minus 4 minus 2, we are going to have 8 minus negative 6. This is going to give us what? 2. So here we are going to have 2 raised to the power 2 times 2 raised to the power 8. So here, once we subtract everything finished, we are just going to bring 2 raised to the power 8 attached to this one, and then just apply the first rule. So 2 raised to the power 2 times 2 raised to the power 8, we are going to have 2 raised to the power 10. Since they are having the same base and multiplying, we are going to add the exponent. So that's the expression for that. Yes. So the third on my list is when a number indices form is raised to another power, the indices are what? Multiplied, right? So we learned about the indices. The indices are called what? The exponent. So here they are just saying that if you have an exponent and then that exponent is multiplying another exponent, all that you are going to do is you just multiply that two exponents together. So here we are having a raised to the power x all into bracket y. So here we are going to have a raised to the power s times 1. So you are just going to add the two exponents. So here will be x times what? Y, as you have seen in this expression. So let's check an example here. We are having 3 raised to the power 2 times all times raised to the power 4. So here what we are going to do is you just multiply the exponents, right? So you are going to have 3 raised to the power 2 times 4. This is going to give us 3 raised to the power 8, right? We are going to have 3 raised to the power 8. And then our second question, we are having 5 raised to the power 6 times 5 raised to the power 8 divided by 5 raised to the power 9, or multiply by our 2, as you can see at the top here. So here we are going to apply our first rule, our first law and then second law, right? So all that we are going to do here is that just to apply the first law here. So 5 raised to the power 6 times 5 raised to the power 8 divided by 5 raised to the power 9, right? So you are just going to do the multiplication finish for the first law, and then when we are done with the multiplication, we come to what? The division. So here we are going to have 5 raised to the power 6 times 5 raised to the power 8. This is going to give us 5 raised to the power 6 plus 8 divided by 5 raised to the power 9, right? So once you are done with the multiplication one, we come to the division one, and then here we are going to get 5 raised to the power 14 divided by 5 raised to the power 9, all squared. So since we are having division sign here, we are going to subtract as we learned. So we are going to have 5 raised to the power 14 minus 19, as you can see here. We are going to have, when we subtract 9 from 14, we are going to have 5 raised to the power 5. And the 5 raised to the power 5 times 2 is going to give us 5 raised to the power 10, as you can see here. 5 raised to the power 10. So that's the third law of what? Indices. And then the fourth law of indices is saying that when a number is raised to a 0 index, the value is 1. Whether the number is a digit, whether it is a digit, it is a number, it is a letter, any letter at all, any number at all raised to the power 0 is equal to what? 1. So here we have a raised to the power 0. A raised to the power 0 is equal to 1. 2748 48 2 raised to the power 0 is going to give us 1. 0 raised to the power 0 also is what? Going to give us 1. So here we are having the same thing. Any number, any digit, any letter raised to the power 0 is surely going to give us 1. So if we have this expression, 7 divided by 8 plus 4 whole number 1 divided by 2 raised to the power 0 is surely going to give us 1. And if we have x raised to the power square plus 2x plus 1 raised to the power 0 is still going to give us 1. If you have 8 raised to the power 0, it's still going to give us 1. So any letter, any digit, any number at all raised to the power 0 is surely going to give us 1. And our next law is when a number is raised to a fractional index, it is what? A root. So if you have any fractional index, it is surely going to give us a root, right? So here we have square root, we have cube root, we have polynomial root, right? So if you see a root there, it is not square root. It is referring to all forms of roots that we are having. So here we are having 2 raised to the power 1 divided by 2, right? 2 raised to the power 1 divided by 2. for that one, we see the half means square root, right? The half means what? Square root. So here 2 raised to the power half is surely going to give us square root of 2. So you see, usually for the square root, you don't bring what the denominator here, right? So here the half is what? Square root. So they are mostly written as square root of 2. And then we have 3 raised to the power half. This is also going to give us square root of 3. And then we have a raised to the power 1 divided by 3. So this is going to give us cube root of what? A, which is always written as that. So usually, in general, all that you are saying is that if we have a raised to the power 1 divided by n, it's surely going to give us n square root of a, right? And then if we are having a raised to the power m divided by n, we are going to have n square root of a times m. Sorry, raised to the power m. So this is how these expressions are being what? Expressed, right? And our next law, as you can see here, is that when a number is raised to a negative index, then we have a raised to the power negative 1. So for example, we have a raised to the power negative 1. It is surely going to be written as 1 divided by what? A. 1 divided by a. So it means that we are just going to bring that number at what? The denominator. So if we have this here, if you are having a raised to the power negative 7 divided by a raised to the power negative 2, you know that we have learned this one. If you are having the same base and they are dividing, what you are going to do is to just subtract the exponent, right? And then here you are having, I'm coming, a minute. Yes, so when we are having, let's say, a raised to the power negative 7 divided by a raised to the power negative 2, right? They are using the division sign, they are having the same. So here we are going to have a raised to the power negative 7 minus 2, which is going to give us a raised to the power negative 7 plus 2, which will give us a raised to the power negative 5. So a raised to the power negative 5, right? So that is the negative 5 we are having here, and this thing can be written as what? 1 divided by what? A raised to the power 5, right? As we can see there. And then we have our next example. As you can see, it is following the example that we just saw. So here we are having a raised to the power negative 7 times a raised to the power negative 2 times a raised to the power 7, right? For this one, we are just having multiplication, and with the multiplication, you are having the same base. You are just going to add the exponent. But since we are having negative in front, what you are going to do is to just, because if you have positive and then negative, the negative overshadow the positive, right? So here you are having a raised to the power negative 7 minus 7 plus 7, which will give us a raised to the power negative 7 plus 7, which will give us a raised to the power negative 2, and then the final answer will give us 1 divided by a raised to the power 2, right? Yes. And then we are having the power of product of two numbers, right? So if you have a times b all into bracket n, right, we are just going to take each of the individual aggregates within the bracket and then just index the index number outside, right? So here we are just going to have a raised to the power n times b raised to the power n, as you can see here. So for this one, we are having this example. We are having 2 times 3 raised to the power 2. So this whole expression can be written as 2 raised to the power 2 times 3 raised to the power 2. Since we are having, they are all raised to the power square, right? We are just going to square each of what? The negate. And then when we further express 2 raised to the power 2, you are going to have 4. When we further express 3 raised to the power 2, you are going to have 9. 4 times 9 is surely going to give us what? 36. And then this expression, you are having a half times 2 raised to the power 8 divided by 2 raised to the power 5, all square, right? So you know that half can be written as 2 raised to the power negative 1. As we said, if we have a negate raised to the power a negative number, we just write the number, we just write 1 and then write the whole of this numerator under what? 1. So this whole expression can be written as what? 2 raised to the power negative 1 times 2 raised to the power 8 times divided by 2 raised to the power 5. So here we are just going to add the first and then just subtract the last. So we are going to add negative 1 plus 8 minus what? 5, right? All raised to the power square. We're going to have, when you add everything perfectly, you are going to have 2 raised to the power 2 times 2. This is which is surely going to give us 2 raised to the power 4, right? 2 raised to the power 2 raised to the power 4. Now last law that we have is the power of quotients of our two numbers, right? We are dividing two numbers with a given index. We are just going to multiply, we are just going to index both of what the quotient, the quotient what digits, right? So as you can see, we have a divided by b, or what, n, right? So you are going to have a raised to the power n divided by b raised to the power n, as you can see here, provided our b is not what equal to what 0, right? And if you have this one to a divided by b raised to the power negative x divided by y, right? If we have an exponent of a fraction which is having a negative sign, all that we are going to do to remove the negative sign is to just interchange or reciprocate the quotient that we have here. So here we have a divided by b, right? So we just reciprocate it. We are going to have b divided by a, or raised to the power x times x divided by what, y, provided our a is not equal to what, 0, right? So this is what we have, right? So this is an example. We said a divided by 9 raised to the power negative 3 divided by 4. We are going to just rotate it, reciprocate it. We are going to have 9 divided by 8 raised to the power 3 divided by what, 4. So these are the laws of what, indices. Take your time and then go through. In our next video, we are going to solve questions using this law of what, indices. See you there. Bye.